Right, welcome back to the class. Now we will talk about landform evolution by means of weathering or mass wasting. So we just talked about mass wasting, that how it breaks down a large hills or cliffs and changes the landscape. And a river does a similar river has a similar effect as it flows over a landscape. It changes the landscape by means of erosion. Um, Here, landform evolution, weathering breaks rocks apart. So we just saw that how weathering uh, breaks the rocks into smaller pieces, and then by erosion, those smaller pieces are carried away from one distance to another. Mass wasting shapes stream valleys. So here is one example of Colorado River. As the river is flowing, you can see here it is undercutting its bank by means of erosion. As it continues to flow, it will continue to erode, and that will continue to steepen cause the over steepening of the bank. And then as the over steepening continues, the slope will become unstable, and then eventually it will undergo landslide or mass wasting, and that will change or increase the width of the river channel, and it will continue over the time, and as the year passes it will continue to increase the width of the river stream. Gravity is the controlling force in mass wasting. So remember that gravity is the main force, because everything is pulled downwards uh, during it's just a natural force which is acting on everything, and the gravity is trying to pull everything downwards toward the surface. And there are other factors which works in the background, but gravity is the main factor which is working around the clock. Slope material is gradually weakened by these other factors, and one of them is saturation with water. Others are over steepening, removal of vegetation, and earthquakes. So these are the main trigger that can initiate mass wasting. Saturation with water is very common. After a severe rainfall event, the soil in the ground is overly saturated with water, and as the soil continue to get oversaturated, it will lose the cohesion. It will become looser and looser. The cohesion will disappear over the time as it become oversaturated, and that will allow the particles to disintegrate and move with the water as it is flowing over that soil, and that will cause eventually over long time it will cause the mass wasting. Over steepening is another factor, where the slope by means of like I discussed last time. So suppose you have a hill like this, and over the year this will cause some weathering, and that will change the slope of this hill, and it will become steeper and steeper, and over the year as it continue to increase its steepness, it will also starts to become unstable. So that angle of repose is that maximum steepness a hill can sustain without undergoing mass wasting. So this is a stable slope at a certain angle of repose depending on the size and shape of the particles. You might have seen all of these flyovers. The side of these flyovers has certain angle of recline, and that angle certainly depend on the size of the material that was used to build the side of these flyovers. You can look at 408 or 436. It's just the side has certain angle of inclination. Over steepening, and another natural force is the stream that I just talked about. As the river is flowing, it is undercutting the bank of the river, and that creates a valley-like structure, and over the time that valley will continue to become steeper and steeper, and that will eventually lead to mass wasting. In the case of marine environment, waves are doing the similar weathering effect, just like a stream. It is undercutting a cliff, and then eventually due to extensive wave action, the cliff will undergo over steepening and then eventually go through a mass wasting event. Human activity, especially urbanization, which changes the landscape, and that can also sometimes lead to over steepening of the landscape. Here are some of the examples. This is angle of repose in the case of sand. In the case of sand dune, we know that over the time the sand dune continue to build, and then eventually it will just completely collapse under its own weight, because the angle of repose becomes so steep that it can no longer sustain its own weight, and it will just simply collapse. And that strongly depend on the type of material which is building this this hill or this cliff. So different material have different angle of repose or stable angle of repose. Triggers of mass wasting. So these are some of the triggers: removal of vegetation, root system that bind sediment, forest fire, deforestation, development, farming. So these are the major causes of removal of vegetation. We know that forest fire, deforestation, where we remove the forest to build or urbanize the landscape, or development, any urban development or farming or another region, to remove the trees. And trees has this property, the roots of the trees are holding those soil in the place. But once you remove the trees, and the rainfall event will happen, that will lead to oversaturation of the soil, and then the soil will lose cohesion and it will disintegrate, and then it will start flowing with the rainfall water. Okay. Sometimes mass wasting events occur without an identifiable trigger, without even earthquake event or any rainfall event that can happen. Once again, a review: what factors control the initiation and nature of mass wasting. Gravity, it's always working in the background, and then there are these other four factors: saturation, oversaturation of soil, over steepened slopes, removal of vegetation, or major events like earthquake. How does mass wasting shape a landscape? One example is mass wasting widens stream valleys. As the river is flowing, it undercuts the bank, and then eventually it causes over steepening, and that leads to a mass wasting event. Now we will look at hydrologic cycle. I have also posted a video that you can go over that will explain the idea of hydrologic cycle. What are the major reservoirs for water on Earth? So reservoirs, the storage places where the water are most commonly stored on Earth. First, the definition of hydrologic cycle: water moves between ocean, atmosphere, and land via the hydrologic cycle. So there are multiple these cyclic process in our environment. Hydrologic cycle is one, which is sometimes also called as water cycle. It basically explains how water moves between atmosphere, on the surface, below the surface of ground, in the rivers and ocean, how the mass of the water remain conserved. So it is based on this law of conservation of mass, which says that any mass in our closed system, in our environment, on our planet Earth, will remain conserved. It is not going to change. So the day the Earth was formed, the planet Earth and the environment around it was formed, since that day to today, the entire mass of the atmosphere, or everything is contained between atmosphere and on planet Earth, is remained conserved. It has not changed. It cannot change actually. That is called as the law of conservation of mass. And hydrologic cycle is also based on the same law of conservation of mass, where the mass of water does not change. It can only transform from one phase to another phase. So it can go from solid phase, like in the ice or in the glacier, into liquid water phase after melting, and then from water phase, it can convert into gaseous phase by means of evaporation, and it can go into atmosphere. But if you sum up the total volume or the mass of water in our planet Earth, in the atmosphere, in the ocean, in the river, it will remain conserved no matter at what time. It can be in different form in the different phases, but the total amount of water on our planet in the atmosphere will remain conserved. So these are the different reservoirs in hydrosphere: oceans, glaciers, rivers, lakes, soil, and living tissue. So these are the major reservoirs where water is found, is stored on our planet or in the atmosphere. Here is a schematic of hydrologic cycle. Three major processes: evaporation, precipitation, and runoff. So precipitation, where the water falls from the atmosphere in the liquid phase on the surface or on the ground. And then runoff is the process where the water is flowing on the surface of ground after precipitation. Evaporation is the process where the water is evaporating or transforming from liquid phase into gaseous phase, driven by the power or from the sunlight. So here you can see that sun is the major driving force which is running this whole hydrologic cycle, something that we discussed earlier in the beginning of chapter, the external processes. So all of these are the external processes. These are occurring at the surface or near the surface of our planet. Evaporation, precipitation, runoff, all three of them are example of external processes, and you can see all of them are driven by or powered by solar or sunlight. Infiltration is the process where water which falls after precipitation on the ground is absorbed inside the surface, so inside the body of the earth. So that process is called as infiltration. Here you can see the mass of water in different phases changes as you go over different landscape, over the ocean. Since there is more exposed water, there is more evaporation, and also there is higher level of precipitation here. But if you go on continental landscape, there is less precipitation, also relatively less evaporation compared to ocean, because the water is trapped, or sometimes it is infiltrated, or it is undergoing runoff. So that volume of water changes as you go from ocean to continent, but the overall volume of water, if you sum up all of these numbers, this number will remain conserved, will remain constant as you go 2,000, 2 million years in the past or in the future. This total amount of water in our atmosphere on our planet will remain conserved. It can change from one form to another, but the total volume will remain conserved. So that is hydrologic cycle. It explains how water moves from one form or from one physical state to another, in this continental state to ocean to atmosphere. So this is a model that explains it. 96.5% of hydrosphere is the global ocean. So majority of water is trapped in the ocean, which is saline water, something that we cannot use for our domestic purpose or industrial purpose or has any other economical value. So majority of water is trapped in the global ocean. About 1.76% is stored in ice sheets and glaciers, and that is also not useful because it is all in the solid form in the ice sheets and glacier, and there is no economical way to recover that water, something that we can use. So that also we do not count as something accessible, something that we can use in our everyday life. The rest 2% is stored in lakes, streams, groundwater, and atmosphere. So lakes and streams are the surface water, the water that flows on the surface of our planet Earth. Groundwater is the water which is stored below the ground, something that we extract by means of pumping well. and then there is some water which is stored in atmosphere in the form of clouds. So this is 2% of the entire volume of water is actually accessible to us, and amongst this 2%, majority of the water is stored in groundwater, which is below the ground. It may seem like we have a lot of surface water because that is something we can see easily in the lakes and streams, but the fact is majority of the fresh water is stored in groundwater. So this once again just try to go over this fact again. Remember, the majority of the water on our planet is saline water. So 96% of the entire volume of water on our planet is saline water. 1.76% of total volume of water is trapped in ice sheets and glaciers, and about 2% is surface water, groundwater, and atmosphere. Okay, so we have only 2% of the entire volume of water on our planet Earth, which is accessible to us for our industrial use, for our domestic use, for farming and irrigation purposes. So remember, that's why the water is a very precious resource that we have, and we need to conserve it, we need to protect it for ourselves and for the next generation. Hydrologic cycle is powered by the sun. Water enters atmosphere from the oceans via evaporation. Evaporation is that physical process where water converts from liquid phase to gaseous phase, powered by solar energy. Wind transport water through the atmosphere. We know that the clouds are driven by wind in the atmosphere, so the water can evaporate at one location, but it may rain farther from that location. Precipitation either falls to the ocean or a continent. Precipitation to the oceans complete the hydrologic cycle. Precipitation to the continents must return to the ocean. So any water that falls on the continent, either it will be absorbed in the groundwater, and if it might flow on the surface of water, if it flows on the surface of water, or even if it is stored below the ground, all of them will eventually flow and fall into the ocean. So that's how the hydrologic cycle completes. The water is evaporated from the ocean and on the surface of the continent. It goes in the atmosphere, and then it falls back on the ground by means of precipitation, and then the runoff will move all this water from continent back into the ocean. Evapotranspiration is one term that occurs in the vegetation. Since we cannot distinguish between the term evaporation and transpiration. So transpiration is a process that is limited only to vegetations of plants. So they have a process by which they release water from the plant body or plant tissues, and that is called as transpiration. And then evaporation is also another term that the plants go through. So they have two distinct processes, evaporation and transpiration, by which they release the water back into the atmosphere. So the two terms are together called as evapotranspiration, and it is only applicable to plant mass. It does not apply to humans or animals. Infiltration, like I explained earlier, the water which is absorbed inside the ground is called as infiltration water. The water that runs on the surface are called as runoff. Just a review, what are the major reservoirs for water on Earth? So this is a short answer type question, something that might appear in your midterm exam. So I want you guys to remember this. The major reservoirs for water on Earth are oceans, glaciers, ice sheets, lakes, streams, groundwater, and plants. Ocean is the most dominant one. Over 96% of our water is stored here in the ocean.